All right, so our actual rate of the plane, or the actual speed of the plane, is going to be my plane speed minus the wind speed. So my equation is going to be 1800, that's the distance, is equal to 4, because that's how long I've gone, there's my t, times my actual rate of the plane, the speed of the plane, which is the speed of the plane minus the wind speed. All right, so I have 1800 is equal to 4 times the quantity of 525 minus w. All right, because the speed that the plane is actually going is going to be 525 minus whatever that wind speed is, or the jet stream. All right, so that's my equation, and then I would just solve it from there. All right, number 4 is essentially the same thing, except for that we are going downstream, which means my current is making the actual speed of the boat faster. All right, so the boats, you know, if it had cruise control, the cruise control would be set at 336, no, it would be set at 2 miles, 2 kilometers per hour. Well, because we're going downstream, it's taking us faster, the current's making us go faster, so I've got to take my boat speed and add the current to it. So my actual rate that I'm putting into my equation is the expression S plus C, or my speed of my boat plus my current speed. Questions on either one of those? Okay. Let's take a look at number 7. I'm going to take a look at 7 first, because I want you guys to understand the logic behind these. Okay. So in number 7, they tell us we have 2 different. We started doing one of these in class, and then we kind of stopped, and I just didn't go back to it. So let's talk about this. In number 7, I want you guys to think about, I have 2 jugs. Here's a jug right here. In my right hand has 200 liters in it. And there's fluid. It's water and fruit juice. There's 35% fruit juice in it. Are you guys cool with that? Okay. In this jug, number 2, I have 300 liters. All right? And there's a certain percentage of fruit juice in that one. I'm pouring them into a bucket. And in the end, I want 500 liters, because I'm going to pour both of those in there, all of it together, and I'm going to have a total of 500 liters in my bucket. Are you guys good with that so far? So I have my start with a bucket of 200 liters and a bucket of 300 liters, and I'm combining them together for a 500 liter bucket. Are you guys good with that? Okay. In that first bucket, 35% of the amount of liters is fruit juice, right? So 35% of the amount of the 200 liters is fruit juice. In the second one, however many percentage of the 300 liters is fruit juice, okay? And then in the total, 20% of the 500 liters is fruit juice, all right? So if I was to set up an equation, my total number of liters of fruit juice is going to be equal to the amount of liters of fruit juice in number 1 plus the amount of liters of fruit juice in number 2. Are you guys okay with that? So I'm measuring the amount of fruit juice, not the amount of total fluid. I'm just looking at the amount of fruit juice. All right, if I look at my whole, 20% of the 500 liters is going to be fruit juice. So if I take my percentage of fruit juice times my total liters, it's going to give me my amount of liters of fruit juice in my whole. I can do the same thing for each of the individual jugs as well. If I take my percentage of fruit juice and I multiply it by the total amount of fluid in that bucket number 1, that will give me the number of liters of just juice in bucket number 1. If I do the same thing in number 2, I multiply that percentage of fruit juice, multiply that percentage times the total number of liters, that 300. that would give me what percentage of the 300 is actual fruit juice. How many of you guys are okay with just that basic idea? So we're just measuring the amount of fruit juice in each bucket. And we're using our percentages of the total fluid to figure out what percentage of that, what the amount of liters of just the fruit juice. Okay, so for number 7, the only thing that's missing is our percentage of the juice, a percentage of that, the total liters at 300, what percentage of it is fruit juice. So there's my X, is my percentage here. So if I write my equation, I end up with 20% or 0.2 times 500 is equal to 0.35 or 35% of the 200 plus my 300 liters times whatever that percentage is. And then I would just solve for that. I end up with 10% fruit juice in bucket number 2. Giselle. Okay. How many of you guys are cool with just this basic idea? Okay. If we take this same basic idea and we apply it to number 6, okay? Number 6 is a little bit more complicated because in number 7, they tell us the total amount of fluid in the 2 buckets, and we're able to come up with the total amount of fluid in the whole thing, right? Number 6, they don't do that. So we've got to be a little bit more conniving, a little bit more thoughtful with number 6. But I'm starting with the same idea. All right, so if I take a look at number 6, hopefully, if I take a look at number 6, I'm going to start again with the same game plan. The total number of liters of juice is going to be equal to the number of liters of juice in the first one plus the number of liters of juice in the second one. So now I'm going to break that down a little bit further, and I'm going to figure out a game plan for how to find those. If I take the percentage of juice times the total number of liters in my whole, that's going to be equal to the percentage of the juice times the total number of liters in number 1 plus the percentage of juice times the total number of liters in number 2. How many of you guys are okay with that basic idea of that game plan? Now the problem is, I don't know. The only amount I know is in this first one is 6 liters. I don't know the number of liters in the second one. I don't know the total number of liters. However, if I say X is equal to the total number of liters in number 2, what expression could you write for the total number of liters in the whole thing? So I know number 1 has 6 liters of fluid total. Number 2, we're saying that this is X. The total number of liters in jug number 2 is going to be my X. What expression can I write for my total number of liters in the whole thing if I put both of these together? Here is my 6. Here is my 2. How could I write an expression for my total number of liters in the jug that when I combine it all together? Lily? Yes. So now I've written my equation and I only have one variable total. So I have 55% or 0.55 times my total number of liters in the end product, the big one, is equal to the first jug, which is 20% or 0.2 times 6 liters, plus 80% or 0.8 times, I don't know how many liters are in there, is times X. And then I would solve for X. Questions on this one? These are harder. And I do recognize they're harder. If I was to give you one, it would be like number 7, not like number 6, where you would have the total amount of volumes for all of it. Okay? How many of you guys got this? Or got pretty close to this? Kind of close to it? Okay. This is one of those ones that I would abandon this one and the distance ones. I would abandon the standard form AX plus BY equals C, and I would fall back on game plans. Is what I did. All right, so now you can kind of see both. Questions on any of these? Okay. So, who needs to see what's up there? All right. Get your notes out, please. All right. So we are moving on with 4.5. So in 4.5, we are going to be talking about parallel and perpendicular lines. Okay, so today is 1-6. We are in Chapter 4, Section 5, and we're going to write equations for parallel and perpendicular lines. Okay. When we talk about parallel lines, what do we know about their slopes? We have talked about this already. What do we know about the slopes of parallel lines? Seamus? Yep, slopes are the same. Okay. All right, so what I want to focus on, if given an equation, we want to write an equation for a line parallel to the given line, but passing through a given point. So this is what we're going to be doing right now. So if given an equation, we want to write an equation for a line parallel to the given line, but passing through a given point, a totally different point. So let's write an example so you know what the heck I'm talking about. All right, so directions are write an equation of the line that passes through -3, -5, and is parallel to y equals 3x minus 1. So, slope-intercept form. All right, so I'm going to do some steps over here to the right, and we're going to do our problem over here to the left. To write an equation in slope-intercept form, so our equation is also going to be in slope-intercept form. So new equation, also in slope-intercept. So for me to write a slope-intercept equation, what are the two things I need? For me to write an equation in slope-intercept form, what are the two things I need? Joseph? So I need my y-intercept, and I need my slope. So these are what, I'm going to move this steps thing down a little bit. These are what we need. All right, so here are my steps. Well, if I'm writing a line parallel to that line, what can I get directly from that equation? If I know that they're parallel, my new line is that line? What can I get out of that equation right away that I know of those two things? L? Yeah, my slope is 3. So the first thing you're going to do is you're going to ID the slope. So my slope is going to be 3 because the slope here is 3. All right, so far I have y equals 3x plus b. So that's where I am so far. All right, the second thing I'm going to do is I'm going to use the slope and given point to find b. Remember, the b is not the b from our given equation. It's a totally different b. It's a totally different y-intercept. It's parallel to this. So I need to take the point, -3, -5, and I need to substitute it into my equation to solve for b. So I have -5 is equal to -3 times 3 plus b. And all of you finish this, please. How many of you guys got b is equal to 4? All right, so somebody write my equation for me now. So I have y equals mx plus b. Somebody write my equation with this. Lily? Excellent. Y equals 3x plus 4. Questions? Yes. Yes. Yep, we're going to be dealing with slope-intercept. Because we need the slope and the y-intercept. If they give it to you in standard form, you need to change it in slope-intercept. All right, so let's go back up here and kind of make a note of that. We're going to use slope-intercept form. So we want to use slope-intercept form. All right, let me give you guys another one. Actually, you know what? We're going to move on to perpendicular lines. I'm not going to be able to give you the time to prove to you why this is the case, but you guys are just going to have to trust me that it is. I mean, you can look in the book and figure out why this is the case. All right, but when we talk about perpendicular lines, if two lines are perpendicular, what does that mean they create? When they, with each other. Seamus? Yeah, they create a 90-degree angle. All right, so when we have perpendicular lines, they create a 90-degree angle when they cross. Now, in your book, this is what they look like. So if I have this line and then we have a perpendicular line, all right, where they intersect, it creates a 90-degree angle, and their slopes are not parallel. Their slopes are not the same, but I need to know what their slopes are. Their slopes are opposite signs, and they're reciprocals. They're opposite signs and they're reciprocals. I call this, they are opposite reciprocals. So let's talk about what that means. If I have the slope of my first line, let's say it's 1/2, what would be, I'm just going to, this little upside down capital T, that means perpendicular. That little symbol is an upside down T, capital T. That means perpendicular. This sign right here means perpendicular. Okay, so what would my perpendicular slope be if the original slope, or the slope of my first line, is 1/2? What would be its opposite reciprocal? Joseph? Yep, that's -2 or -2/1. All right, these are just examples. So let's say my first slope is a negative 3/5. What is my perpendicular slope? Carmen? 5/3. It's the opposite sign and it's the reciprocal. Are you guys cool with that? Okay. So now what I'm going to do is I want you to tell me, I want you to write an equation. So I want you to write an equation of the line that passes through 4, -5 and is perpendicular to y equals 2x plus 3. God bless you. The process of this is exactly the same. The first thing you're going to do is you're going to ID the slope. All right, so what's the slope in my given equation? What's the slope in my given equation? Natalie? 2. All right, what then would be the slope in my perpendicular equation then? Rita? -1/2. Okay, so I found my slope. The second thing now is you need to find your b value. It's exactly the same thing that we just did when we had our parallel lines. All right, so I have y equals mx plus b. All right, so I'm using 4, -5 because that's the point that we know that our line goes through because it says it's going to go through that point. So I'm going to do -5 is equal to a -1/2 times 4 plus b. And I'm just going to finish that math. Somebody write my equation for me now. Ryan? Plus -3. Did I get a negative? You guys got a negative, right? Excellent. So plus a -3. All right, let's talk about parallel lines and perpendicular, parallel lines for certain. Okay, so if somebody says to you, are these two lines parallel or perpendicular or neither? All right, so let's talk about whether we can determine if two lines are parallel or perpendicular. All right, so we want to determine if equations for lines are parallel, perpendicular, or neither. What's the first thing you are going to look at for those equations to determine if they're parallel or perpendicular? What's the first thing you want to look at, Joseph? So we need to look at slope. All right. When we have parallel lines, they have the same slope, but what about their y-intercepts if they're parallel? Natalie? They're different y-intercepts. When we have perpendicular lines, all right, we have opposite reciprocal slopes. That's all we're looking for. All right, so what I want you guys to do is I want you guys to determine if any of the three lines are parallel or perpendicular. So A is going to be y equals 5x minus 3. Line B is x plus 5y equals 2. And line C is negative 10y minus 2x equals 0. So there are my 3 lines. I need to make sure they're all in slope-intercept form. So all equations must be in y equals mx plus b. So all of you change those so they're in that format, please. That first one already is, so I'm just going to circle it because I know I'm done with it. All right, I'm going to do B. Go ahead, you guys do it as well. Remember, you need to solve for y. Now, when you're doing this, divide each term individually on part B by that 5. So if I have negative x over 5, what is my b value actually? I'm sorry, my m value. What is my coefficient if I have negative x over 5? What is the coefficient of that x? Rafaela? Not just negative 1. Yep, negative 1 over 5. So it's negative 1/5 x plus 2/5. I'm going to do the same thing with my c. So on this one, I get y is equal to a negative 1/5 x. So if I look at these, are any of the lines parallel? Are any of my lines parallel? Line A is y is equal to 5x minus 3. Line B is negative y is equal to negative 1/5 x plus 2/5. And line C is negative 1/5 times x. Are any of these parallel? Carmen? Excellent. B and C are parallel. What about perpendicular? Are any of the 3 lines perpendicular? What do you think? A and B. A and B. Are any other ones perpendicular? What about A and C? Aren't they perpendicular as well? Yeah, and that makes sense. Why does it make sense that that lines A and C would also be perpendicular if lines A and B are perpendicular? Why would that make sense? What do you think? They do. They're parallel. So if line A is perpendicular to B, it has to also be perpendicular to C because B and C are parallel to each other. All right, so to determine if 2 lines are parallel or perpendicular, you need to have it in slope-intercept form and you need to identify those slopes. You guys cool? Okay, you guys can go.